So today I will start with a short update on the user interface source code you got. I didn't provide a video from last time because it was so bad. So there was a small user interface. So I put out a link to the previous video that I did last year. So it should be the same except for these things here with the Qt5. In the old examples, I had PyQt5. So that's the only difference. But I also want to show you the reason for why they become, how you can solve the problems with stamp size user interfaces. So as you probably know, many modern computers have really high resolutions on the screens. So for example, this has was retina display, so you can't see the pixels. That also means that if you design your user interfaces with pixels, the user interface library has to be able to take into account that there is a really high resolution screen. And sometimes Qt can kind of get confused, and it uses the actual pixel size for the user interfaces. So it doesn't rescale it. And there are ways of, it should handle that automatically, but sometimes you need to enable that feature. And so this is the Beam UI I showed on the lecture. And if I scroll down to the main section here, you can see here that you can set options here to enable these features here. So it's important that you do it before you create application object. So here is the set attribute first for and enable high DPA scaling. That means that it converts the pixel sizes you use is not the actual ones, they are kind of compensated for the high resolution display. And there's also one, if you use toolbar icons, it also enables you to use the high resolution versions of your icons as well. So these two here, if you set them to true, it will handle the scaling automatically. So now I'm running at high resolution here. It's not, you can't see it on the projector here, but on my screen here I have I think it's over 4K display. So if I run this now, you can see here that now the user interface is as the correct size. So, and you can also see it if you have a Mac or Windows machine. If you move your window from the high resolution screen to the lower resolution, it should change automatically. It's very clear on Windows. If you move it outside, it rescales the user interface either up or down, depending on the resolution of the monitor. So now it's scaled up, and it's useful. I also just show that just to illustrate. And then also I have all the examples in the source code is updated with this. So if you download it, it should be able to run regardless of you have a high resolution screen or not. So, and then I wanted to give you some examples of a little bit larger apps that provide a little bit more functionality. So the first app I'm going to talk about is an application that queries a public API on the web to get data and display it as a user interface using Matplotlib. So what I will do now is, I don't have a problem in two parts. So I told you before that it's important to separate functionality of your computational model or your data models from the user interface. So in this case here, I've decided that all the communication with this API will be handled by a class called SMHI. So SMHI is a meteorological institute in Sweden. To be able to easily use that on my user interface. So I don't have to bother with the user interface details in my, the model, the request for this API in my user interface. So the API is located at this URL here. So I have decided to store it as an attribute URL. The API looks like this. This is the string following the URL. And there are certain places here with curly brackets that you need to provide your own information here. So there are some things that I'm not an expert on this API. I just found it on the net and tried to implement this. And So you have to specify the first position here is a PMP3G, and then what version of the API to, and longitude and latitude has to be provided here. So I have added those parameters for the API as attributes, and then I have created a method called request forecast that will do the actual query the API from the web and retrieve the data, download it. And the data is provided as JSON, which we have looked at before, as a way of storing data automatically. So from the API, we will get back a JSON response. So API string here, I put it together using the formatting strings here. So I will category, version, longitude, latitude, that goes in, and it returns you a string with the correct API call. And then there is a special module here that you need to load for this application to run. So if you do conda install requests, you can get this method here, and requests you can use that to call URLs and request data from a URL with the HTTP GET method. So here I call request GET. I combine my URL with my API string. And then the return here is a string in JSON format. And I need to convert that into something that I can read from Python. So loads here will convert the text to a Python dictionary structure which you can query. Then I also added some other method here to extract param names. So that method will go through the JSON and figure out all the parameters available in this file, which it returns. I have a method here to extract a single parameter from the data. And it loops through the forecast data here to extract different, and you get back here, it returns you a series of dates and the values associated with each date. An example of using here is it down below here. So this is not a user interface. I just want to show how it works. So I create an SMHI object by instantiating this class here. I extract the param names here using the SMI extract param names, and I get the list of available parameters. And then I can extract a single parameter, for example, R, and I get date times and values from the extracted data. And then here the plotting things here is just to illustrate what's actually going to happen here. So if I run this now, it just shows a plot like this. So here you have values on the y-axis here, and you have the date times here when this values was from which time it was taken, like this. So now I want to provide a easy to use user interface for this object I created here. So instead of using it from the command line, I want to use it from a user interface so that the user can enter what parameter I want to query and also automatically plot inside a separate window. So what I did then is I opened up my designer and I created a user interface here, a form, which I have a parameter here. So what parameter I want to plot. I have also, if I want to select longitude and latitude and press refresh. And when you press that button, it will query the API on the web again and update the database of values. You can see here also I have the object structure is laid out here. I have my main widget. I have latitude edit, longitude edit, param combo, and refresh button. So I usually do those objects I need to request in the code. I give names that are logical so I can access them. So usually I have, if you have a text box, I usually add underscore edit, so you know that it's an edit box. If it's a combo box, I add combo. If it's a button, I underscore button, and so on. So you can remember them in your code. I save this. Then I go to my weather app here. So here's a lot of import statement here, probably too much, but the important thing here, if you want to use matplotlib inside a Qt application, you need to have certain controls that can handle that or implement that. And if you look here, matplotlib here has a backend. So matplotlib can be implemented on Qt, it can be implemented on BX widgets, it can be implemented on several different user interface toolkits, and every of those toolkits have a backend in matplotlib. And as we are using doing a Qt5 application, we need to get access to the Qt5 backend, and then we have to get out a figure canvas that can be drawn as a control in Qt. And it's called really strange names here. So what you can do in Python is you can import them and set them with your own names. And also have a navigation toolbar. That is a toolbar in matplotlib. You can also import that as a control. So I import them and give them reasonable names. I can't create them directly in the designer. So you have to leave space for these controls in the Canva, in the designer when you work on that. Then I imported some matplotlib normal import here with PLT, and this is for not mticker is a way of reducing the number of dates produced in the plot, because otherwise they overlap and you can't see anything. So this is a special object that we use for that. I import my SMHI object here for my SMHI module. You can see here I have in my same directory the SMHI source code file. By just putting it, calling it smhi.py, it can be imported as a module. So in this case, I import smhi as a module. So I inherit from a Qt main window. So this is a window that can have a main menu and a toolbar. I init my upper level main window instance. I also, this is something can be useful at certain points when you run your application, that you actually store where the application is located. So sometimes when you install application, you need to access files relative to the application directory. So this is what I do here. I sysarg0, or the 0 argument when executing the program is actually the script that I run. And then I split the path and I just take the directory. Then I have my application directory. And then I load my user interface file here. So UIC load UI, weather app UI, instantiate it directly in my user interface or my window object. So I provide self here. Then UIC will add those objects to the window object. Of course, I need to access my SMHI object, so I instantiate that and as a attribute in this window class. I need to create a figure window. So here I create a figure that is a standard plotting window, and I create a canvas object to be able to insert that into the Qt user interface. And then I also create a navigation toolbar, which I can insert in the user interface. So here you can see here I have my main widget. That is the same name as I gave here. This is the main widget. And the main widget has a function called layout, which returns the layout of that main window. And I add the widget to that layout. So first I add a canvas, so that will be on top. Then I also tell it that it should expand and take as much room as possible. And then I add the second widget here, which is the toolbar, to the layout. And so that will be on the lowest part. And then I initialize some, I have my combo box here. There is a signal called current text changed, which I will connect to self on text changed. So when the combo box is changed, it will call this method. I will also connect the click signal from the refresh button to self on refresh. I usually, when I code user interfaces, I prefix the methods with on. Every method that is connected to signal. I have on, that's easy to read, and on text change, that is kind of an event. So just to kind of differentiate them with normal methods that are called by other classes or part of your code. Then I request a forecast, I update the controls, and I plot. So request forecast is what you saw before here. Here, it will use the SMHI object here to extract the params, and I also get the time, the dates and the values from that param. Then the second part, update controls. I set the values in the combo box, and then I plot here. So when you have instantiated a matplotlib figure in a control, you can just do the same. You do the same thing here. You set figure clear, access, and then you plot date. I do the same thing that you do standalone. And there are some other things, some technical things that I need to draw and flush events, but that is sometimes certain widgets have their own quirks that you need to handle. But basically, I draw it on the screen here. So if we run this here, you can see here that I have, first I have the user interface we designed in Designer. Then I added the figure, the canvas here, and then the toolbar on the bottom here. So here also all the parameters that I queried that were available in the API are listed here. So I think T is temperature. And if I click that, it will plot again. And then you can do refresh to actually call the API once again to get more data. Now it's not updated all the time, so it's the same data here again. So this shows how you create your model that you want to, either it's computation model and this is a data model, encapsulate in a easy to use object, and then you call that object or instantiate in your user interface. But on the one hand, the good thing with this is that this object here can be reused somewhere else. So you can take this and you can do a web interface instead. So that's why you shouldn't mix your kind of implementation details with the user interface, because otherwise it's hard to separate them later on. So this was a weather application. I will also show you a bit more complex application. Both of these are in the UI folder, in the cases folder. So there is one beam app and there's one weather app. So you can look at them yourself, how they're implemented. So I will now look at the beam app. This is more complex application. So you can see here that, so this is a finite element, a very simple finite element application for calculating forces in beams. And I have divided it up into several modules here. The main functionality is in the beam model module. And this is the model that implements the computational part of this code. So the first thing here you can see, I use an external library called PyQt5, which is a toolbox for finite element code implementation. I also have NumPy. I have JSON here for loading and saving files. So the beam model here, I define some constants here. These are, if you define variable in your class, they will be available to all other classes. So they are not attributes that are available for each, or unique attributes for each object you create. These will be the same for every object you create. So I have implemented, let's see if I can do like this here instead. So if we look at the beam model, it has a new method to create a new model. So basically initialize the model from scratch to default values. There is a solve method for solving the model. There is a save as JSON, so you can save the model to disk. And there is an open from JSON that you can load the model again from disk. So here I have initiated the beam model here. The lengths are stored in lists. So the first beam section is 2 meters, the other one is 3. There are 10 segments, computational segments in each beam, or 20 in the second. I have loads here, supports, and other properties. And there are some other variables here. In the solve section here, I compute the solution to the beam problem. It reads from the properties section here, assembles the stiffness matrix and all that stuff, computes all the results, store the results in different variables here. And there are some variables here you can access. Then you can see here the save as JSON. We have a dictionary here, which I store everything in. So I store the length as the key lengths, and then I just store the different attributes of the model inside this dictionary here, and just dump it to disk. Same thing, I go the other way around. I load it from a JSON file. I get the dictionary, and I store the values I got from this dictionary in this file here. So you can run this separately here. So here is an example how to run the beam model standalone. So you create the beam model instance, you set the length, you set the segments, you set the supports, you set the loads, and you compute solve, and then it calculates the values here. Okay, let's. I didn't run this example for a long time, but this should be beam model here. So I use these constants here to define the supports. Let's see if I can run it now. Yeah, nothing happens here. So it will basically solve the problem and store the results inside the beam object. So I will not run the entire program just to give you a feeling of how it looks at the final version here. So beam app is the main application with the beam window. So this is the completed user interface. So here is the geometry view of the beam. So for those not familiar with structural mechanics, this is a beam which is fixed here. There's a rolling support here and a rolling support there. These blue ones here are the loads. And then here is the deflection is plotted. And then you have the section forces and the bending moments here. So how would you implement this? So what I have here as well, so if we go to beam app, beam window, so this is the main application. It consists of just the main window, and there's views of this model in different ways. So I have implemented a class that's called beam view that takes as input the model, the beam model, and also a figure. And then the beam view draws the model on the screen. So if we go into the code here, beam view, it uses another class here to implement the drawing here, but this is to make it more easy to understand here. I get the beam model in here. I store it internal here, both the figure and beam model inside here. So we have references to it. I define some other variables that are for the visualization. I set up the plots here. So basically it's set up so it's using subplot feature of Matplotlib. And then I draw the diagram here. So here I get my section forces here from the B model. It stores all those. I get maximum values here. Also, I calculate those. And then I do my plotting here. Just not normal Matplotlib. Then I also have a special method for drawing the geometry, because the geometry there is no really good function for plotting the geometry. So I have implemented this as a separate routine for drawing the geometry here. So there's more complicated commands here. But basically this encapsulates all the drawing of the model. So it produces a view of both the geometry and also the results of the B model. Then you need the user to be able to modify your model. So one obvious thing is you have to specify the segment. So I can show you the user interface for this. If we start with the main model. So this is the main user interface. I will just shrink it a bit here. So it's based off a Q main window. You can see it here. This is Q main window is the entire screen. There are menus here I have created here. I can create them inside Qt Designer as well. I have a toolbar here, and I have defined all the actions that are available. So you can design the actions inside the designer as well. Then I have defined here a main layout where I want the Matplotlib to go. So this is a section here where I will insert the figure plotting or the model view object. If I go back here, and then if I run the program here again, I will show you how it will look. The user interfaces for inputting the input data. So if I want to change here, I have two options here. I have beams and supports. So beams here will display the properties for the different beam sections. So I have 3 sections here. I have a segment length. I say also calculation points. That is how many calculation points it should divide up the beam when solving the problem. I can also specify a load, Newton per meter. So it's a distributed load. And I can specify the material for the beam as well. And then if I click here, I can change here the segment I'm working on. So you can see if I press 1, it will display 2, and then 3 here. Also, if I change here to 3 here, I press update, you can see it recalculates automatically in the behind here as well. And if I go back again to like that. I can also add more beams here by pressing the plus and minus signs. Support. I have 3 beams. I have 4 supports, and here you can change the different kinds of support. So on the right side here or left side, I have X and Y locked. Second support is only locked in Y direction. Same thing with the third, and the fourth here is fixed. Both the position and also the rotation is fixed here. So how do we implement those user interfaces? So if we just look at so this is the layout of the user interface. There is a tab widget here, which is a special widget where you can have multiple areas with different controls. So if I press the switches here, you can see that it only displays the controls inside a certain tab. And you can also see it in the object structure here that you have tab widgets, tab, and then you have some controls. I have tab 2, controls, tab 3, and additional controls here. I also named everything that all the controls here. For example, the area here is called A text, E text, I text, just to be able to find the controls easily when you code later on. Also have the update button, it's called update button. You can also see here I use this spacers here to push up the controls so that they look better. Same thing, I wanted the button to the right here. I had a spring here that pushes the button to the right. I also have these plus buttons here called add segment, remove segment. So if we go back to the code here, if we go to the segment section here, I had defined a beam segments window that derives from the Q widget. When you instantiate here, you give it a beam model and a beam view. The beam model, of course, because that is what you want to edit. The beam view is to be able to call update and redraw the section. So you need to kind of, this update button needs to be able to talk to the view to refresh. I load a user interface like this. And then I connect all my signals here below. I have a method for updating the list, updating the controls, updating the model here. So when you have the controls, you need to be able to add or modify the length and segments and loads in the model. Here I also have, if anything goes wrong here, it goes back and updates the control. So it's if you enter some wrong value, it will take the default values from the model and apply them again. Then if you do, it does solve and draw. Of course, this is a very small problem, so you can actually do the solving of the problem inside the user interface here. But otherwise, it could be, if it's a long time running, you should have the solve button inside your main window and perhaps run the computation in a thread. And then if you look at the beam model app here, so if I do segments action triggered, I have on segments here. So if I go down to on segments, you can see here I create a beam segments window instance, and I show it here, and I pass over the beam model to the user interface, also the beam view. So I kind of delegate the editing to this module, and you do all the editing of segments inside this class. Draw just this. Yeah, this draw view here is a utility class here for implementing some of the plotting that I do for the geometry. Feel free to use it if you feel it useful as well. So that was what I wanted to show here, and oh, the draw where I didn't want to run that. I'll run that one. I want to also show here that you can actually, it's quite flexible, the toolbar handling here. So all this functionality you get for free, you can put the toolbar anywhere in the user interface here. Also, if you want to have graphics in your application, in the toolbar, you need to create something called a resource file. And it's called QRC. Let's see here. You use a special compiler to, I don't have it now in my memory here, but it will generate a file called beam.res here. So there is a resource compiler here, I think it's called QIC. I will get back on that, but it will generate this file and embed all the graphics that you have provided into this file as a source code. So in my Beam app here, at the beginning, I import beam.res. I don't have to, there is no code to call, just imports all these images in a way that it can be provided in the user interface. So you create a QRC file. Those files you can create inside the designer, where you just add the images here to the files, and then from that you compile and you get a resource.py file here. So that is the I wanted to have this larger application to kind of give you an idea how to implement something that is a bit bigger than just simple applications. So the beam application is a complete application that can solve section forces moments on a beam, and so it's feature complete in that sense. It doesn't handle much multiple load case and stuff like that, but it solves a single load case. So that was what I'm just to stop recording here.